in this problem, we're asked to find the Maclaurin series for the function 3 times ln of the quantity 2 minus x, and also find the radius of convergence. So we're really looking for the first 4 coefficients here, and then we're going to apply the ratio test to get the radius of convergence. In this problem, we don't need to construct this series from scratch, because we know, right, if we recall, that we have ln of 1 minus x, right, we said was equal to this series, starting from 1 to infinity x to the n over n. And we know this converged from including negative 1 up to 1, right? Not including 1, and that was the interval of convergence. So this series is related to the given series, 3 ln of 2 minus x. So what we're going to do is a little rearranging of this, or rewriting of this. 3 times ln of 2 minus x is really equal to 3 times ln of 2 times the quantity 1 minus x over 2. I just factored out a 2 there. And then I can use the property of logs to rewrite this logarithm as a product. So this is going to be 3 times ln of 2 plus ln of 1 minus x over 2. And then I can go back and distribute that 3. So I'll have 3 ln of 2 plus 3 times ln of 1 minus x over 2. Now we have this logarithm. Well, this first term is just a number. That's just a constant. This one, you'll notice, is in the form 1 minus something. So it's 1 minus x over 2. So we can say that this is really equal to 3 times the series, starting at 1 to infinity. But instead of an x to the n, I'm going to have an x over 2 to the n over n. And now I can just simplify this series a little bit, and I'll get 3 ln of 2. There's a minus here, so I'll just make it a minus 3 times the sum from n equals 1 to infinity. And I'm just going to parse this out, and so it's x to the n divided by 2 to the n times n. Okay? And then we can just rewrite this series a little bit, right? So you'll see this will be 3 ln of 2 minus 3, and we'll just expand the series. So when n is 1, you're going to have x over 2, right? When n is 2, you'll have x squared over 2 squared times 2, which is 8. When n equals 3, you'll have x cubed, right, over 2 cubed, which is 8, times 3, which is 24, right? And I think we'll get one more. And then when n is 4, you'll have x to the 4th. 2 to the 4th power is 16, times 4 is 64, right? And I should say this is going to go on infinitely, right? Dot, dot, dot. But really, these coefficients are all being multiplied by this negative 3, so I'll just kind of write it out like that. So we have 3 ln of 2 minus 3 over 2 times x plus, still minus, they're all minus because this is minus, so it's minus 3 over 8 times x squared minus 3 over 24 x cubed, and then minus 3 over 64 x to the 4th minus dot, 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 right? So you can see C0 is the first term, 3 ln of 2, right? C1 is what's in front of the first degree term. That's going to be negative 3/2. C2 is what's in front of the second degree term, which is negative 3/8. C3 is negative 3/24. And C4 is equal to negative 3/64, right? So we have the first four coefficients as requested in the problem. And now we want to consider the radius of convergence, right? So if you look at the series, right, the series looks like this. Again, it's 3 ln of 2. We can kind of ignore this. This is just a constant being added to the series. Minus 3 times the sum from n equals 1 to infinity, x to the n over 2 to the n times n. This 3 outside is not going to affect the convergence status of this series. So really we want to look at this series, this one in the red box, and we're going to do a ratio test to check out the interval of convergence. So apply the ratio test. And we'll do that. We'll say the limit as n goes to infinity. And you can see it's going to be x to the n plus 1 over 2 to the n plus 1 times n plus 1 divided by the reciprocal of this, which is really multiplying by 2 to the n times n over x to the n. And you can see you're going to have one factor of x left in the numerator because this will cancel out, right? You'll have one factor of 2 in the denominator. This will cancel out. And we can pull those outside the limit. So we'll have one factor of x in the numerator, one factor of 2 in the denominator, times the limit as n goes to infinity of n over n plus 1. Okay? And you can see this limit is headed for 1. And so the final limit is just equal to the magnitude of x over 2. And so the limit, by virtue of the ratio test here, is magnitude of x over 2. And for convergence, right, we require, or the ratio test requires that the magnitude of x over 2 should be less than 1. Which means that the magnitude of x has to be less than 2. So you can see since it's centered at 0, right, this is, the radius is going to be 2, right, so 2, negative 2, right, x has to be between 2 and negative 2. So that radius of convergence is 2. Alrighty, I hope this helps.